Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong learning event brought to you by SentinelOne and AWS. My name is Cody J. Brown. I'm the host of Techstrong Learning. We've got an exciting program ahead. Before we begin, I do have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude this live session. If you want to engage with our panel, you can do so using a couple of our options on the right side of the screen. The first of which is the chat tab. So I'd like everyone listening right now to go ahead and use that chat tab. Let us know where you are joining us from. Now, if you have any questions for our panel, I want you to direct those to the Q&A tab. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program today. So our topic is securing Kubernetes with SentinelOne and AWS. I'm joined today by Amit Sharma, product leader at SentinelOne, Howie Howerton, cloud engineering manager at SentinelOne, and Josh Dean, senior solutions architect at AWS. So Amit, Howie, and Josh, thank you all so much for joining me today. Amit, would you like to go ahead and take it from here?
Thank you, everybody. Welcome. It's great to have you here. So let's dig in. So my name is Amit Sharma. Let's do introductions first. So my name is Amit Sharma. I do product marketing at SentinelOne. So I am joining you live from sunny California. Well, it is sunny at least today. So I joined SentinelOne about a year and a half ago. Before that, I was part of a Splunk in the similar role. And before that, SignalFx and AppDynamics. So I've been in this monitoring, observability, and security space for quite some time now. But the majority of my career has been as a DevSecOps software engineering role. So I'm certainly looking forward to this webinar. Howie, do you want to introduce yourself and tell us where are you joining from?
Sure thing. Hi, everybody. I'm Howie. I'm a SE manager for the cloud workload security team here at SentinelOne. Been with SentinelOne about 3 years and joining today from currently sunny Mooresville, North Carolina, just north of Charlotte.
Very good. And everybody, we are delighted to have Josh. So Josh Dean is joining us from AWS. Josh, do you want to introduce yourself and tell us where are you joining from?
Yeah, so hi, I'm Josh Dean. I'm a partner solutions architect at AWS, which basically just means that I get to work with awesome partners like SentinelOne. I'm joining you today from a town called Perth, not in Australia though, Perth, Scotland, just outside Edinburgh, so you have to make the distinction. So yeah, you're outside Edinburgh, Scotland.
Very good. So we are coming to you from all across the world. That's great. So let's take a look at what are we going to talk about in the next 45 minutes or so. So we did introduction. So Josh is going to take over from here. He's going to talk about Amazon EKS and container offerings that Amazon has to offer. Then we will take a look at Kubernetes attack vectors, threat modeling, audit logging in Kubernetes, and how to implement certain use cases. We will walk through SentinelOne Singularity Workload Protection, our cloud and Kubernetes protection defense platform. We will do a demo, and we will spend quite a bit of time in demo, and then we will have time for a Q&A. And as Cody mentioned, we will have time towards the end of the webinar to take question and answer. But if you have any question, please feel free to ask in the Q&A tab. So with that, Josh, take it away, and let's start telling people why EKS.
Thank you. All right, let me get it pulled up here. All right. Yeah, so I already introduced myself, so I can skip right ahead. Just going to talk to you a little bit about Amazon EKS, or Elastic Kubernetes Service. Just so you can get an idea of what it is if you're not familiar with it, and why we recommend it. So there's a lot of reasons teams choose EKS, right, or Kubernetes in general. It has a vibrant ecosystem and community, has consistent open source APIs, a lot of flexibility. So customers rely on Amazon EKS to handle the undifferentiated heavy lifting of securing and operating Kubernetes at a large scale. So EKS provides the flexibility of Kubernetes with that security and resiliency that you know of being an AWS managed service. And EKS is optimized then for customers building highly available shared service platforms based on open source. So customers like Intel, Snap, Intuit, GoDaddy, they all trust EKS or Amazon EKS even to run their most sensitive and mission critical applications. So if you're a customer that is adopting Kubernetes, you probably want that open flexibility, and you should start with EKS. So we recognize, though, that you might not be starting from scratch when you build on AWS, specifically on EKS. You may already have chosen to use Kubernetes as the core and have some existing tooling, right? So EKS gives you the ability to bring the services that you want and to build in a flexible way and in a flexible environment. So, of course, if you want to use EKS with all of the native AWS services, you can do that too. And we continue to prioritize Kubernetes-friendly integrations with innovations like ACK, which is AWS controllers for Kubernetes. I'm an old networking guy, so when I see ACK, I think of TCP SYN-ACK. So still not quite there yet, but ACK for AWS controllers for Kubernetes. One example then being such as the CSI for the add-on that we have for EBS. So EKS and also ECS, which is kind of our basic Docker container service, they both manage how you run containers, but you still then have to have that compute layer underneath, right? And AWS gives you a full range of integrated compute options for where you can run them, right? So you can choose the right tool for the job, get the right blend of cost, performance, and features. So for both EKS and ECS, you have the option of running containers on Fargate, which is kind of a serverless container compute engine, where you just pay for the resources you use or the resources that are required to run your containers. So if you don't want to worry about managing servers, handling capacity, or figuring out the isolation of container workloads, Fargate's a great option. Obviously, you can run it on EC2 instances. Gives you that wide range of instance types for processor-intensive storage networking. Really, you can optimize for your workload. You can also run on AWS Outposts, which, if you're not familiar with, is kind of a on-premise or in data center rack of AWS. So you can run your containers there. Same with local zones, which are sort of like mini regions. Wavelength for low latency 5G applications. And then also with EKS and ECS anywhere, you can run them in your house if you want. So really anywhere. So as companies containerize more of their applications, right, they find that those applications can require persistent storage. So this is because those applications are long running. They need persistent state for high availability, right? Or even because an application wants to scale out around sort of a shared data set. So there's a lot of options here. You can kind of see just a few of them on the screen. I don't want to spend too much time on this, but you can see where you can get into integrating with some of these sort of underlying persistent storage engines, that sort of thing. Okay. Just overall, there are a few challenges that associated with running EKS clusters. First of all, setting up a network, right? Containers need to join a network in order to send and receive traffic. So for that, we have obviously Amazon VPC, which you probably come across. And if you didn't see, I think it was only yesterday that the general availability release of a service called Amazon VPC Lattice as well, which really simplifies the way that developers connect to secure and observe communication between those services. Containers also need to be able to discover one another and do so using services like AWS Cloud Map. You may want to deploy a service mesh to set up another application level network that allows you to control network traffic and routing. That you might use App Mesh or STO. You could also, load balance traffic, incoming traffic based on layer 7 protocols like HTTP, or even layer 4 with just TCP and UDP using ELB and AWS load balancer controller within the cluster. And we also have an ALB ingress controller on the cluster, which allows you to, use network load balancers, share those ALBs with multiple Kubernetes ingress rules, create new target group binding resources, and just create support for fully private clusters as well with your load balancers. Okay, so just to take a look at operations really quick. One of the reasons we're here, obviously talking with SentinelOne, is security. Security we consider job zero at AWS, and we have some services that help you. Again, I won't go into all of these, but just you can kind of see the story with, we're kind of trying to cover the security pillar of the AWS well-architected framework, if you've come across that. Between identity and access management through detection, infrastructure protection, data protection, and incident response, right? The full suite of services available. And then additionally, customers have to maintain operational excellence and resiliency, right? As well as optimize for costs and performance efficiency across container applications. So customers must be able to provision the infrastructure that their applications run on. And they must be able to set configuration audits and manage cluster patching, right? And lastly, they need end-to-end observability over their applications, from API logging to infrastructure monitoring to application logging and analytics, and I'll show you some of the ways that SentinelOne can help you with some of this as well. And then just kind of quickly to sort of wrap it up, 2 more slides, I promise. We have an AWS native toolchain set of sort of open source toolchain that both work seamlessly with container services. So AWS provides services for the modeling and application of the infrastructure, right? Source code and container artifact management, build and integration tools, and the ability to test and deploy into production and monitor the application as it runs. And you can see some of those services there. And again, I think I heard it would be recorded. So if you're interested in one of those, you'll have another chance to go back and find out what it was. And we at AWS work really closely with the open source community and AWS partners across the chain, right? So you can see some of them listed here again, but just to give you the idea, we have our own services, and then we work closely with open source as well. And yeah, that's all I have to say, Amit. So back over to you.
All right, very good. Thank you, Josh. So let me pull up my slides and share my screen. Awesome. So there was a comment in the chat, like, why securing Kubernetes? What are the considerations in securing production clusters, and why is it difficult? Distributed systems like Kubernetes and microservices. So let's go back sometime in the history and see where did we start and how the life was good. So everything was a monolithic system, right? So like a Java application running on a physical server or a virtual machine, everything was running within one JRE, and there was no traffic going east to west. So put a perimeter defense, and then you're good to go, right? Our life was, as security professionals, our lives were just say easier. But what happened? So systems start to change, right? So systems change from monolithic systems to distributed systems. But then we just started to break these services into multiple microservices, which increased our attack surface. So let's go to Kubernetes architecture. So this is distributed. right? So we have multiple components supporting Kubernetes, our infrastructure only. So even if you are just running a pod, kubectl create pod, that just one simple command might create 50 to 60 different objects on Kubernetes. So there might be some storage, networking, services, deployment, ingress controller, like so many other things that are happening behind the scenes. And these make the attack surface. So any of these things can be attacked by attacker. API server, and they get hold of API server, they could get hold of anything, they could do anything. And the key value is stored at CD where Kubernetes is stored, it's a state that can be attacked as well. So in terms of threat modeling, they are, again, looking at the entirety of these attack vectors and the surface. Anything can be attacked. But today we are going to talk about pod and container breakout, and we will talk about RBAC on the right-hand side of your screen. But there are so many other things that can be attacked. So in our Red Teaming the Cloud webinar, we will cover other aspects. But today we're going to look at pod and services as well as some RBAC best practices. So what is the first step? First step is instrumentation, getting data in. Looking at all the events that are happening across the cluster, as well as your workloads that you are running, your operating system, your infrastructure. So why eBPF? So SentinelOne uses eBPF. So let's answer why we are using eBPF. But before we do that, let's see what else is available. Our challenge is we want to capture and monitor runtime events, especially in a distributed system like Kubernetes, at which the data is moving. Events are created at a very high speed, and huge volume of data is being created at high speed. And we want to do that without impacting the performance and stability of operating system. So what else is there? So if you look at the landscape, some of our competitors, some of other solutions that are available in the market, they are using different approaches. So let's see what those are. So first, you just change the Linux kernel, right? Now that is not feasible, not practical, because your change has to be very broadly applicable to be adopted by the community. And then Linux kernel get released like a very slow cycle, right? So last major update happened 4 years ago. You can write a kernel module and then change the behavior of the kernel. But then if you update your kernel to the next kernel major version, then your kernel module may not work. So system admins, as security professionals, we are apprehensive of installing kernel modules in our systems. And it can affect the stability and performance of our kernel. Another approach is run a container as a sidecar. So you have a pod, you want to capture data from that. So you have an application and a container running in a pod. You want to capture data from that. Then you can run a sidecar container alongside that application container within the same pod. The challenges is it increases the overhead. Not only from the infrastructure perspective, CPU, memory, you are running another container which is doing this interception of work, but from cost perspective too. And it increases the attack surface. So you have to be now worry about that container that you're running as a sidecar. And to limit the overhead, what other solutions do, they sample data. So they do probabilistic sampling. So they would only capture data like 13th minute of the hour or like certain times of days, which creates blind spot. So you're not looking at real time all the data. So sidecars do not work for that reason. So why eBPF is ideally suited for implementation? So eBPF basically, it is you can run your programs as a sandbox within the kernel. So eBPF allows capturing system call events within the kernel, and as I said, it runs in a sandbox within the kernel, and it can deny the user space applications from making certain syscalls. So using setcom. So it is safe, it is fast, it is agile, and it is lightweight, and it is secure. So that's exactly why we are using eBPF. So how does it work? This is an illustration that I'm showing. So if a process in the user space, here I'm trying to open a file, it is running and it is going to make call and the syscall. So there are eBPF hooks that you can get into and get the data. And for those events for which eBPF hooks are not available, you can write kernel probes or user probes, and you can get all the data to enrich the event that you are capturing. So, for example, you can get file path and all the contextual information about that path, and then you can send it back to through the probe to the user space agent, which is capturing this data, which can then send to the SaaS service on the cloud platform. So very neat architecture and a way to capture data. So now that we have captured event data of everything that is happening inside your operating system and workload, let's see how do we, what are we looking for, right? So what should we look for? So as you guys, some of you guys know, if you're coming from platform engineering or SRE background, so there is a golden signals for SREs. So this was made famous from Google, so red metrics or use metrics. So similarly, from security point of view, what are the things that we should be looking for? So we should be looking for process, right? Process creation, inter-process interaction. So one process is trying to spin off another process and create a process chain, how they are interacting. We should be looking at file system operation. So if a file is open or a change in a file has happened, so we should be capturing that information. We should be looking at network connections. So if it is making any calls on the network, we should be looking at DNS or layer 7 calls, right? Because that's probably the biggest or the main reason why an attacker would get hold of in our infrastructure. So with this, so that is the challenge, and let's see how do we solve this. So this is an introduction to SentinelOne. So SentinelOne, so as you guys know, that we are a leader in EDR space. Today we are talking about cloud workload security. We acquired a company called Ativo. So we have a very robust solution on identity and incident response and managed detection and response space with our Vigilance product. Now, all this data is going into security data lake. In the bottom, you are seeing some data sources which are ingesting all this data. And I'm going to talk about security data lake and how that can help you understand and triage and troubleshoot and resolve issues, not only just from your workloads or your nodes, but also anything that is happening across your Kubernetes cluster. So let's take a look at our cloud workload protection program. So we talked about eBPF instrumentation. So it's cloud native eBPF. Instrumentation which gives you agility and lightweight nature of data instrumentation. There's no need to modify kernel or install a kernel module, and then you capture all the events across your production clusters. So you have visibility and for forensics purposes. Howie is going to go a little bit detailed on the detection engine. So once we have data, what do we do with it? So we have built a detection engine. So it's not only just based on file hash or reputation. So we are also looking at from machine learning and AI perspective, what is a workload, how it is behaving once it is deployed, and how if we see any anomalous or suspicious malicious activity, then we can detect it. We can also resolve it on your behalf, and how he's going to take a look at that. And by the way, you control the policy of whether you want to detect it or you want to protect it. So by automatically, it can take the remediation step as well. So this is active cloud protection. And we have custom detection star rules that Javi is going to tell you about how you can create your custom detection rules as well. So I want to touch a little bit about Kubernetes audit logging, because this is part of best practices. Everybody should be doing audit logging, because this gives you X-ray vision of what is happening inside your cluster at any given time, or also for the historical purposes. So let's take a look at what is audit logging. So auditing is a chronological set of records, right? So anything that is happening, a kubelet is talking to API server, a scheduler is getting ready to schedule a pod is getting scheduled, right? Any event that is happening, it is being logged in Kubernetes audit logging. And the cluster audits the activities by users, applications, and the Kubernetes API, as well as the control plane. So what does it give us? So it tells us, for example, these questions, right? So what resource was accessed by without an authorization, by whom, when did that event happen? If you want to ask a question, hey, who deleted that pod, or who scaled the replica set to from 4 to 100? From where did that action was initiated? So all that information is being recorded, and it is there for your forensics purposes if you want to go back and check and create a threat model for your production cluster. And Kubernetes, as you know, is open source, so all the source code for audit logging is also available. So it is a part of audit.gates.io API group, and you can find out what are the audit stages and what sort of audit logging like levels are available, what you should be doing. So the great thing about Kubernetes is it's all open source, and everything you can review and take a look in the source code itself. So let me just talk about stages. So so there are like 4 stages: request received, response started, response complete, and panic. And these are whenever the API server gets a request to do something, and then it responds. So these are different stages of auditing on the Kubernetes cluster. In terms of level, so none is obviously it does not capture anything, but you can capture metadata across requests. This will have user, the IP address, the timestamp, but it will not have the request response body. And you should not log the request body, at least, because what if your service account is trying to get a secret, right? You do not want secret in the plain text. Although it will be encrypted, but base 64 encryption is not very strong, right? So people can get around it. So our recommendation would be do not log the response, the request body that is coming in the cluster. So with that, let me pass on to Javi, and he's going to walk through SentinelOne product and walk you through some of the vulnerabilities and threats and how would you go detect and protect against those vulnerabilities. Javi, please take it away.
My mic is still muted. Here we go. Thanks, Amit. So what I've got up here now is the SentinelOne Management Console. And in the console, I've got 2 Kubernetes-based agents. So a 2-node EKS cluster, 1 agent per node. The reason there's 1 agent per node is that the agent deploys as a daemon set, which has its own set of advantages in that it auto scales along with the cluster. So if I were to add a 3rd node, we would have a 3rd agent that's automatically scheduled and installed and communicates with the console. And we would see that and administer it here. Another good thing about the agent is that it is metadata aware. So it can pull metadata from both the AWS to give you things like account IDs, VPC IDs, even custom tags. And then it also is able to communicate with the Kubernetes API. So you can understand things like which cluster it's deployed on, which node, and all associated labels. And you can use this metadata along with any of the available agent attributes to dynamically group any of your agents within the SentinelOne console. So for example, what I've done here, as part of the hierarchy inside of my site, I've got these dynamic groups. And I've got this dynamic group based on the fact that the agent is a Kubernetes agent, and it's also running within AWS. I could add other, tertiary or fourth attributes to say, okay, it matches this cluster name or this set of labels as well. But the overall message is that you can base these dynamic groups based on any combination of those attributes, which gives you a lot of flexibility. So whatever your provisioning process happens to be, your SentinelOne policy, as indicated here at the top, all the configurations can follow suit with that provisioning process. Speaking to policy, just sort of outlining some of what Amit was sharing earlier. Policy in SentinelOne's, I'd say, drop dead simple, and that you have a set of toggles, one toggle for malicious threats, like high confidence threats, that you can use to perform preventative action, protective action, such as invoke a kill and quarantine. You also have a secondary toggle for suspicious threats, so things that look and act like malware, but you can't say with the same degree of confidence that, yes, absolutely, it's malware. So for that, we give you this secondary toggle to just detect and then log all of the context around or associated with that threat. We've also got all of the different detection engines that we'll see here in the demo, from static AI, which is looking at attributes of files, extracting them and comparing them against a local pre-trained model to look and see if those attributes align with known malware families. Also, we have a powerful behavioral AI engine, which constantly monitors process activity from the system. So in our case, we'll see processes launching a container, so containerd or Docker launching a PID1 process, and then from there spawning the rest of the processes that make up the container. And we'll get to see all of that activity as we attack it and see it all in full context from start to finish, which is another one of the powerful aspects of SentinelOne, in that we can see the entire storyline associated to a threat, which helps us make better decisions, and it also helps in threat hunting activities later on, in that you can pivot from one finding. Say you're looking for one IOC, you can quickly pivot on the storyline ID, the unique identifier, to reveal that same extended storyline. So you can really understand how a certain network connection came into being, or how a file came into being, all the way back to its roots. We also have another interesting control for containerized environments called application control. What this does is it helps you preserve immutability of your containers. So I'd say roughly 90% of the time containers are designed to be immutable, and that they don't change from the time that the developers put the code into the original image. Whenever that image is instantiated, it's not expected that you'll see any additional executables or scripts coming into the container. If they do, that's when application control can step in, alert you to the fact that, hey, this rogue executable or script is trying to execute, and can take action against that. So it helps reduce the overall attack surface. Another interesting aspect of the solution is deep visibility. This is what we call or the friendly name for our endpoint detection and response telemetry data that's streamed directly from the agents to our backend security data lake. So you can pick and choose which things are of interest, like process activity, file system activity, network activity, etc. You can stream that in real time. So even if the container happens to go offline, or it's restarted, removed, killed, then you can still review all of that forensic data very easily within the SentinelOne console. We'll take a peek at that. All right, that said, with the policy reviewed, we'll come in here to our sample application, which is DVWA. Just need to get this set up here quickly. So DVWA, if you're not familiar, is a vulnerable on purpose web application whose intent is to teach PHP developers how to defend against the OWASP top 10 style of vulnerabilities. I'll use this command injection section because it's the easiest to see or to follow visually. And the I guess thing that allows for this command injection to happen is this input box. You can see it's asking for a simple IP address that under normal circumstances it would ping and show you the output of that ping. But as an attacker, we're able to inject other commands in behind the expected inputs to run any commands of our choice. And the form will take it, pass it to a backing exec routine, and carry out those commands. So the command we'll issue is this curl command to download this script.shell file, save it to the file system, mark it as executable, and then ultimately execute that script. So I'll go ahead and punch submit here. And if you're thinking about this as we're going along, since we're introducing that script into a running container, obviously it's running, we should see that that triggers that application control engine that we spoke of, that immutability engine. I'll clean this up a bit. Let me show you these, which lo and behold, there it is, application control triggers. And we've also configured the engine to just log based on any suspicious findings. So we're able to monitor other behaviors that the script carries out and alert and show you everything about what those activities are. So one of the things that it does, or one of the first things, is it downloads this Doki elf binary to the file system. And whenever it hits the file system, the agent will effectively look up its hash. So it's a basic reputation engine, right? Sees that it matches a known bad and it dubs it as a malicious confidence. So we'll go ahead and take a mitigation action to kill and quarantine that file. Great. No problem. It's kind of what you would expect from a next-gen AV vendor, any of them. Just showing that, hey, this works for Kubernetes and containers the way that you would expect that it would. Similarly, static AI engine is also in effect. So what we're showing here is that we've downloaded a close cousin of that original binary and injected a couple of random ASCII characters such that whenever it hits the file system and we perform the reputation lookup, there's no match. However, the static AI will extract, again, those file contents, compare them to the machine learning models, pre-trained machine learning models, and it can assert whether or not that is a known malware. In this case, yes, it is. It's associated with Doki malware family, and we're able to alert on that. Again, kind of par for the course from what you would expect. The real interesting bits are in this application control and behavioral AI alert. And so I'll click in here and we'll be able to see some of the details of this alert. So again, this was all invoked by the application and behavioral AI engine. It saw these high-level behaviors on the right-hand side. So it looked like a web shell, accessed credentials in a strange way, looked for security software, and executed an obfuscated script. And this was able to lead us to at least a suspicious verdict. Now, we're still observing. We haven't mitigated at this point. So if we were to see more malicious behaviors, that could send us into a malicious categorization, in which case we would kill quarantine. So we're still observing. In the meantime, this application control and behavioral AI event started with this curl file. And that file, or binary, was located at this overlay file path. So right away, we know that we're dealing with a container. Specifically, it's running a Docker container runtime. So we may already have some questions in the back of our mind, like, okay, it's a container, but where is it? Is it on a Kubernetes cluster? Is it running an ECS? Is it running on-prem? What's the deal? And we'll show some context on that's pretty valuable with determining some of those answers. We can see the command line arguments that binary was invoked with. There's our downloading of the script. It's already tips us off to, okay, this is how application control was triggered. We downloaded this rogue thing and likely executed it as a next step. See the process that the user ID that the process was running as, so the data user, Apache user. But again, getting to that context, where is this running? We can peek down here at the endpoint details and recognize that this is the common host name convention for AWS for the EC2 services, they'll look like this. But the real context that we're looking for is behind this Kubernetes tab. So now we can quickly and easily understand exactly which cluster this container is running on, which node of that cluster it's running on, which namespace it's in, controller type, so it's a single pod deployment in that case, which pod name and associated labels. Labels is usually the best piece of context as the SOC analyst, because a lot of times you'll have these labels that are actually used by deployments and other controller types. But you'll have things like app equal DVWA, environment, owner tags sometimes. Those are great clues to let you know who you might be able to alert and what the application actually does. We even got the container information here too. So the actual name that's running on this node, the image that it was sourced from, the registry, the repo name, image name, and the tag, and the exact container ID that it's running as right now. You've also got the cloud service provider metadata. So you can see account IDs, VPC IDs again. And this is all, again, great context to have whenever you're responding to an alert. Now, getting to some of the reactions. So we studied this a bit. We see the high-level details. If we want to see low-level details, we can come and explore the storyline, the process tree. I'll just expand this here quickly. And you can see lots of great details. So here's PID1 of the container, launching main.shell, launches Apache, launches other things. Where it kind of goes sideways is around this point in time. Oops, sort of fast forwarding here for you. But here's where you can recognize what we put into the DVWA form, which is kind of cool. You can see that was what it was supposed to do. Now it's supposed to ping it 4 times and then probably return to the originating process. But instead, it got told to do some of these other child processes. So it launched the script that was downloaded, launched this Python process. And here's a base64 encoded script. It's actually a reverse shell in Python. So this is the obfuscated script that's referred to here by these higher level threat indicators. So this is kind of the easy 10,000 foot view. If you need details, Explorer window is there for you to help satisfy any curiosities you may have. But once you understand that something is malicious, you have a couple of different ways to respond. First, you can disconnect a pod or disconnect the entire host, sort of isolate it from the rest of the running environment. If you so choose, that sort of buys you some time to do other forensic collections, if you will. If you disagree with the verdict, you could always add it to an exclusion. Definitely not the case here. We actually might want to do the opposite, which is add it to a blacklist. It's kind of an efficiency mechanism in case you see the same set of command line arguments over and over again, DDoS style. You could add it to a blacklist and block it using a simple string match, as opposed to spending other cycles doing behavioral engine analysis. You could opt to run a script. So these are part of the remote ops package, where you can run either scripts provided by SentinelOne in response to a threat, or even your own scripts that you upload and manage to do various things like run a forensic toolkit, to code collect files, to get a process memory dump, what have you, and very flexible. You can even integrate with third parties. These are commonly used for integrations with things like Okta or your SOAR system, with even other CSPM tools like Wiz, for example. Those are all invoked via XDR response actions. The most common action here is this mitigation actions. So we will go ahead and perform a kill and quarantine on this entire storyline. We can do our case resolution here, mark things as resolved, add notes, could be anything, and apply an analyst verdict to this alert. I'll go ahead and click apply. We see our note is entered. We have these toast messages telling that an action is underway. And we see that our job status is now pending, so kill and quarantine. So when the agent now picks up this job from the management console and carries it out, it'll check the storyline sequence. This is the graphical version of that, but it will try and kill any process that's highlighted in this storyline sequence. If it's still there, it'll kill it. If not, it'll flag it that it's not there. And then it'll also quarantine any files that were dropped by any of these processes. So we can see that that's done now. It's killed 24 processes and quarantined 4 files. But there's an interesting byproduct whenever you kill a process in Kubernetes, and that if PID1 is one of those processes, PID1 in the container, that is, it will cause the container to delete or self-delete, in which case Kubernetes will spin up a replica. So if I come here and say refresh or just click around in the application, you'll notice that I'm prompted to relog in. And when I do, notice that I'm prompted to reset up the DVWA database. So I know that this is a brand new container. That old one is gone, which is great, and that we've been able to clean up from this attack. But as the forensics investigator, you may start to panic a bit and say, Howie, what'd you do? You just killed the container. How am I supposed to do forensics on that? And we say, well, all is not lost. Actually, they're in a pretty good spot because SentinelOne, the agent, is forwarding all of that metadata, that telemetry data for processes, network, and files to the backend data lake. And all you need to do to access it is simply click on the storyline, the unique identifier, pivot over to deep visibility, adjust your time sequence. So I think I did this within the last hour. It was probably like 5 minutes ago. And I can go and ask for all of the telemetry events that match this storyline, that unique storyline. You can see there's there are 164 events associated. Some are process related, some file related, some network related. You even have like the high level indicators there that tell you why something was a threat to begin with. So lots of great information here. One other detail that you have, if I expose one of these process events, is that you also have the container level details. So that same set of attributes, the cluster name, node name, et cetera, all the way down to the container level information, all of this is here for you. And you can actually use it in your queries too. If you want to query on, say, a certain set of labels in here, great, no problem, you can do that. And do that in combination with others. So just simply start your queries with type K8S, the abbreviation for Kubernetes. You can see I can search on cluster names, namespaces, labels, or if maybe it's ECS that you're working with, and I just want to look for different container level information. I've got name, labels, the digest hash, image name, and ID. And then I can combine that with any of the other 200 plus attributes that are available in deep visibility, EDR. And once I have my perfect query, we'll just pretend this is our perfect query, you can save these as custom rules. So if it's maybe a threat hunt that you were performing, maybe you didn't have results this first time, but you want to continue to observe. And if we do have a match, you want to be alerted. That's a perfect use case for custom rules, or even third-party intel data. If you want to query based on that, no problem. You can even invoke, so let me go through here quickly. There's the condition. It will take what's provided back here, but you can invoke responses. So if you do see something that's of dire interest, and you want to slam down the gauntlet, if you do happen to see any activity associated with it, you can set up your rules to do that. So invoke a response to treat it as a threat. And you can invoke your suspicious or your malicious policy against that, and or isolate that endpoint or that pod from the rest of the network. So pretty flexible system, a lot of power in there. We could probably go on for forever and ever here, but I'll stop my demo here, and I'll return the reins back over to Amit to show you one last item.
Very good. Thanks, Javi. Very comprehensive. Let me share my screen and let's see if I do it correctly this time. All right. So I want to show you how to turn on audit logging in different Kubernetes implementation. Here we are looking at EKS, Amazon EKS. So I have a dev cluster running. As you can see, this is running Kubernetes 1.23. And turning on audit logging from EKS cluster is like really, really simple. So you go on logging tab, and then there is audit log availability. So you say manage logging, and then turn on audit logging. And what we do, so once you have turned it on, so we can grab all that logs that is coming from your Kubernetes cluster into our security data lake. So you can correlate every information from your workload to infrastructure to Kubernetes control plane and audit from one single place. So here you are seeing I'm getting all these event logs from our cluster that we were just looking at. So now what I can do, I can search for anything, right? So I was talking to you guys about an RBAC example. So what I did on this production cluster is I impersonated, as a developer, I impersonated an admin user and then tried to delete the default namespace. Because if I can get admin access, I could do anything, right? So obviously my RBAC policies declined it. So if I just search this, like, by the way, I want to talk a little bit about our security data lake. So this is built on a platform called Dataset, and which powers the backend for entirety of SentinelOne XDR. And this is real-time performance at a petabyte scale. So we get trillions of events every single day for all of our customers. And you see how quick the query was, even if it was like a free text search. So here I'm searching for forward. And then you can create a custom rule for that, which will alert you. But here you are getting the entire event and what happened, all the context around it. So a username called dev tries to delete a namespace. So RBAC is correctly not allowing it. That username dev cannot do this. It is forbidden. But you can, as a security analyst, security engineer, you want to know these things. Who in your organization is either maliciously getting access to admin or by mistake is trying to do something which they are not supposed to do, which can wreak havoc in your production Kubernetes cluster. So with that, we have come to the end of our presentation. And we are open for question. And I was just looking, there are a whole bunch of questions. So please feel free to ask any question in the Q&A panel. So let me take first question. The first question is this agent deployed on each node individually, or can they use Helm chart or Helm packaging? Howie, do you want to take that?
Yeah, great question. We do use Helm. We provide a Helm chart that allows you to quickly and easily deploy the agent onto your Kubernetes clusters, your EKS clusters. It deploys as a daemon set, so it's one of the resources that gets created through the application of the Helm chart. And that daemon set ensures that there's one SentinelOne agent pod that's deployed on each of the Kubernetes nodes within your node pools.
Thanks, Javi. So there's another one for you. Is SentinelOne available on AWS, or is it available on other platforms? So I can answer that. So SentinelOne is it protects in native Kubernetes. So whatever flavor of Kubernetes you're running. So AWS is obviously our partner. It works on EKS. But if you're using some other cloud provider, then it will work just as easily and as well that you just saw. If you're running Kubernetes DIY, right? So you are implementing your own, or you are running Kubernetes on EC2 instances or at some other platform within your data center. So that'll work as well. If you're running OpenShift, this will work just as well. So whatever the flavor of Kubernetes that you're running, SentinelOne Cloud Protection will work on that. Another question is, so you showed DVWA tool. Can we run in a pod container on our own? Yeah, so the answer is yes, right? So you can run, the DVWA stands for Damn Vulnerable Web Application. It's an open source application you can run. Be careful. Do not run. Never run on production. So if you have a sandbox, feel free to red team your configuration, your dev cluster, or wherever you want to run, but do not run in production. Let's see. How are cloud details determined? Is it from the agent or from some other configuration or setup step?
Yep. So it is the agent that is getting the metadata from the local metadata service. So of each EC2 instance service, in the case of AWS here, we're both IMDS V1 and V2 compliant, and we can pull all the metadata from those services. For Kubernetes, there's actually a sister container called a helper, S1 helper, that communicates with the Kubernetes API to give us all of that rich Kubernetes metadata that we saw in the demo. But it acts as sort of a broker for each of the agents in the cluster. The agents ask the helper for that resolved metadata for its particular event, and it gives it all the data it needs, and that's shared upwards with the console.
Great, thanks, Avi. So there are a couple of questions. I'm going to combine them. So this is about data collection and data lake. So the first question is, how much data does a container create? And second question is, how long the data collection set is available? Is there any time for live options, storage, database capacity is needed? So I can take the first one, like how much data container creates is basically depends on the workload. What workload is doing, and from the audit point of view, like how many workloads have you deployed on the cluster to get audit data on that? Howie, do you want to take the second one? How long is the data retention for this?
Yep, it's optional retention. So the default out of the gate is to provide 14 days worth of retention for all of your agent data, telemetry data, but it can scale all the way up to 3 years worth of retention. So there's the increments are 14, 30, 90, 180, 365, 2 years, 3 years are your options.
Awesome. Question and probably will end here. Does SentinelOne help with shifting security left by doing more security scans in the CI/CD pipeline, or do we need a different solution?
Yep. So for that, I can say SentinelOne is laser focused on runtime. So think all the way right in that spectrum, watching process level activity, measuring it for malicious behaviors, file objects being dropped to the system. That's the core focus of SentinelOne today. We are, and I guess, partnering with companies like Wiz. There's a recent announcement that was made. Wiz operates in that CI/CD pipeline. They can provide the scanning of the templates, of container images, and give you the general config and posture management functions. And then we can share data back and forth between each other to give you a full spectrum of how your security stance in the cloud is, both at config time, shift left, and shield right, we call it, with the SentinelOne platform.
Very good. So we have other questions, but we are at the top of the hour. Thank you so much, everybody, for attending today, and thank you for your engagement. This has been a really, really good session. We appreciate you joining and for your engagement. Cody, back to you.
Thanks, Amit. And to Josh and Howie, thank you both for joining us today as well. I really appreciate all of your shared insights. So I would like to remind our audience today that the session was recorded. So should you want to rewatch, you will be receiving an email with a link to access the recording on demand. Or of course, you can find it living on the Security Boulevard website at securityboulevard.com/webinars, and be sure to look in the on-demand section. The 4 winners of our $25 Amazon gift card giveaway are Siva K, Quang P, Ali R, and Osita C. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in about the next 48 hours. But if you don't happen to see that email, check your spam folder just in case it got filtered out. I'd like to thank AWS and SentinelOne for sponsoring our program today. And to our audience, thank you so much for being with us for the past hour. We really value your time, and we want to hear back from you. So as soon as we close out, there will be a survey that pops up. Let us know what you thought about our program today, or perhaps what you'd like to see on an upcoming program. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Amit, Howie, Josh, thank you all once more.
Sure.
Thank you,
Cody.
everybody. Bye.
Bye.